Hello students. So next question is the time required for 10% completion of a first order reaction at 298 Kelvin is equal to that required for its 25% completion at 308 Kelvin. If the value of A is 4 multiplied by 10 to the power 10 second, calculate K at 318 Kelvin and energy of activation. So here we talk about A, as question says that here Arrhenius equation is applied due to A value. So first we write what is Arrhenius equation. K is equal to AE minus EA by RT. So this is Arrhenius equation. Now we take log of this equation. So this will become, so here we take log on both sides. Log K is equal to log A minus EA by 2.303 RT. Here log A value is given, that is 4 multiplied by 10 to the power 10 second, and EA we have to calculate. R value is gas constant value and temperature is 318 Kelvin. So we have to apply the formula here. First we calculate the EA value. So how to calculate EA value? First of all we write the equation for calculation of EA value, that is log K2 by K1 is equal to EA by 2.303 RT. Here log K is also not known, so from this we calculate log K value and EA value. So here R is gas constant, EA we have to calculate, and here 1 upon T1 minus both temperature is given, that is here 298 Kelvin and 308 Kelvin. Both temperature is given. So here log K2 and K1 value we have to calculate this. How to calculate? First we note that here time is given, that is 10% completion. 10% completion is equal to time 25% completion, given at 308 Kelvin. So what's the formula of first order reaction? We write, now here we write T at 10%. So how to calculate this rate constant at 10%? We write 2.303 first order reaction K1 log 100 by 90, as we have solved in previous question. Here where 90 comes from? If 10% is given, so total percent upon minus remaining time, that is 10% is equal to 90%. So from this we calculate this, and here at time 25% we write 2.303 upon K2 log 100 upon 75. So here log 2.303 cancel by 2.303, and here 10 by 9 is remaining, and here 4 by 3 is remaining. So how to write this? K2 by K1 is equal to log K2, how many? 4 by 3. 4 by 3 upon log 10 by 9. So from this we calculate the log value here. After calculating, it will become log 1.333 upon log 1.111. So after putting this value, this will become K2 by K1 is equal to 0.1249 upon 0.0457. So this will become equal to K2 upon K1 is equal to, so this will become equal to 2.733. So this is K2 by K1 log value, that is 2.733. Now we put this value in equation this first equation. So log K2 by K1 is equal to log 2.733 is equal to EA we have to calculate, and upon 2.303 R value is gas constant. We put in first equation, that is gas constant 8.314. Here R is only there. So 1 upon T1 temperature is what? T1 temperature is 298 Kelvin and second temperature is 308 Kelvin. So that will become equal to 1 upon 298 minus 1 by 308. Now we solve this equation. So log 2.733, that will equal to 0.4367 multiply by 2.303 multiply by 8.314 is equal to EA is equal to 1 upon, now after taking LCM this will become 298, sorry 308 minus 298 upon 298 multiply by 308. So after solving, this will become EA is equal to 0.4367 multiplied by 2.303 into 8.314. Multiply by 298 multiply by 308 upon 298 minus 308, that is equal to 10. So EA become equal to 76745.71 joule per mole. So this is how we calculate, or we can write in kilojoule. So that will become equal to EA is equal to 76.745 kilojoule per mole. So from this we calculate EA value and K2 by K1. First we calculate K2 by K1 value from the time first order reaction, and then we calculate the EA value. Now we put all this value, EA value, in equation this. So that will become equal to log K is equal to log A minus EA upon 2.303 RT. Here R we know gas constant, temperature is 318 Kelvin it is given. So we have to calculate at 318 Kelvin, and EA value we know, and log A value is also we know, 4 multiplied by 10 to the power 10 second as given. So now putting all this in equation, log K is equal to log A value minus EA by 2.303 RT. So we have to calculate log K value as question is given. Calculate K at 318 Kelvin. So log K is equal to 4 multiplied by 10 to the power 10 minus EA, that is 76.745 upon 2.303, gas constant 314 at what temperature, that is 318 Kelvin as it is given. Now we calculate this log K value. First here log A value is given, so log 4 value, that is log 4 value and log 10 value. 10 we can write this log 4 value, that is 0.602 plus 10 log 10 we can write this 10, because log 10 value is 1, minus, after calculating this will become 12.604. So log K value is 10.602 minus 12.604, that will become equal to minus 2.002. Now this value is in negative sign, so we calculate the anti-log. So this will become K is equal to anti-log minus 2.002. So after antilog, here k value will become equal to 9.954. Now this antilog become equal to antilog of 0.998 multiplied by 10 to the power minus 3. So after calculating, it will become 9.954 multiplied by 10 to the power minus 3 per second. So this is the value of k value of equation at 318 Kelvin. So this is how you will calculate. First you write the Arrhenius equation, and then you have to calculate from Arrhenius equation EA value, and after calculating EA value, here log k2 by k1 is not given, so from time we calculate k2 by k1 value, then putting this value in this equation to calculate EA value, and after EA value calculation we put the value in this equation, that is Arrhenius equation, and from this equation temperature at 318 Kelvin and EA value we got the value k is equal to 9.954 into 10 to the power minus 3 per second. So this is the answer. Now next question is, the rate of reaction quadruples when the temperature changes from 293 Kelvin to 313 Kelvin. Calculate the energy of activation of the reaction assuming that it does not change with temperature. So here temperature changes from 293 to 313 Kelvin and rate of reaction is quadruples, means 4 times increases when temperature change from this to this. Calculate the energy of activation of reaction assuming that it does not change with temperature. So here first we write Arrhenius equation, k is equal to AE minus EA by RT. Now we know that here 2 temperature is given, and we have to calculate again energy of activation in this reaction. So this will become equal to log k2 by k1 is equal to EA by 2.303 R 1 by T1 minus 1 by T2. So this is the integrated form of equation, Arrhenius equation. Here both temperature is given and gas constant is given, and rate of reaction is given quadruples, means 4 times. Suppose initial reactant is R1 and it moves to final reactant concentration R2. So in that case it changes 4 times. So we can write this R2 by R1 is equal to 4 times, or we can also write K2 by K1, concentration increases by 4 times. So here we put value, here K2 by K1 to 4. So this will become log 4 is equal to EA we have to calculate 2.303 multiply 8.314 1 upon first temperature, that is 293, second temperature is 313 Kelvin. Now log 4 value is 0.6020 and EA upon 2.303 multiply 8.314 upon here 313 minus 293 upon 293 313. So this will become 20 after subtracting. EA upon 2.303 by 8.314 20 by 293 313 0.6020. So moving towards left side EA, whole equation become 0.6020 multiply 2.303 multiply 8.314 into 293 multiply 313. So that will divided by 20. Now after solving this all equation we get 52.864 kilojoule per mole. So that will be the answer of energy of activation when there is temperature changes from 293 to 313 Kelvin. So this is how you will calculate this, and that's also the end of the chemical kinetics question. So if you have any doubt regarding this or previous question, you can ask me in comment section, and keep practicing so that your concept become more clear. And thank you for watching.